Moving on now to PFAS-free thermoplastics and composites. It's a very similar story to elastomers in that we already have an extensive PFAS-free thermoplastic product line. The example that I want to share related to PFAS-free plastics and composites is an example related to wear compounds. I mentioned this at the beginning of the webinar that Greene Tweed has an extensive line of thermoplastic composite wear parts. These parts are designed to enhance safety and efficiency of pumps and compressors, where we've got a lot of friction, a highly abrasive environment, perhaps high temperatures and aggressive chemistries. It's no surprise that in a lot of these applications, fluoropolymers are used. Fluoropolymers have very low coefficient of friction, very good high temperature performance, very good chemical resistance. The approach that we are taking, looking at PFAS-free, is by using PEEK-based materials, so polyether ether ketone, by utilizing our expertise in the polymer chemistry and cross-linking chemistry, and again, in our ability to formulate and then ultimately design a part that makes use of whatever material properties we can enhance here. And we think that we have a technology that is a key enabler for us to get into PFAS-free wear compounds, and that is our patented cross-linking technology for cross-linking PEEK. And what we see is our ability to cross-link PEEK enables us to improve the limiting PV. So PV is a measure of tribological performance. It's a combination of pressure and velocity. So how hard can you push on it and how fast can you spin it? But we can increase this limiting PV by 50 to 100% at least versus standard PEEK with our cross-linking. And so what you can see is that there's a demonstration of this in the bottom left. You see a couple of images. These are images coming from an ASTM D3702 thrust washer test. And now caveat here is the materials that I'm showing here do contain a PFAS filler. But basically the compound on the left is a PEEK wear grade that is not cross-linked. And the images on the right are of a cross-linked PEEK wear grade, very similar formulation, but uncross-linked versus cross-linked. And you can see in the uncross-linked material, pre-test versus post-test, you can see the deformation and degradation of the material, but the cross-linked one is basically untouched. And what you can see is we can actually improve upon the tensile strength. If you look at PFAS-free A versus benchmark A, we can improve upon the tribological performance. And we measured chemical resistance. Here I'm just showing the change in tensile strength when exposed to a Norsoc M710 fluid at 195 C, 168 hours. We have other chemical resistance data, but this is just to demonstrate better chemical resistance. Similar story with PFAS-free B and PFAS-free C, where you can see we improved the tensile strength, better tribology, and in the sample that we tested in chemical resistance, it's pretty good. It's better than the control. So again, we think we've got very good high temperature properties here, good tribological properties compared to PFAS benchmarks and chemical resistance. This is another one we would love to identify some specific applications with customers where we could take this as a starting point and optimize these compounds and bring them to market.